So hello everyone, welcome to today's presentations. We are entrepreneurs who are working with the Australian government on a project called Closing the Gap. The aim of this project is to reduce the disparities in life outcome and opportunities between Aboriginal and Torres Strait Islander Australians and non-Indigenous uh, Australians. First, I will tell you how our website fits the marketing criteria. To do this, I will go over each web page to show how it is designed, how it works, and how certain websites satisfy the needs of our listener. First, we have satisfied the requirement of subtype A and B of level 1 from showing our homepage with some clean buttons. Some buttons are on the left of our logo and on the right of the main outcomes, our persona, and a mission statement. And when you click on a mission statement, it will scroll out you to our logo and introduce to our website and how our website address the social challenge. Scroll down a little bit, you will see the video clip of closing the gap of Australia's Indigenous strategy. Scroll down a little bit more, you will see how can we use this site that we mainly focus on the outcome 1, living long and healthy lives, and outcome 5, achieving potential through education. We have shown our long-term health conditions, our current age, and highest level of education attained that are our closing the gap main outcome focused on. We will show you our overview, the regional analysis, disparity analysis, and gap projections. Under here, we will have the gift of showing how you guys can use the button in outcome 1 and outcome 5 pages. And next to this area that we will show you a table that showing the regions of our own region in Australia and populations of 2016 and 2021 that calculated in a database. At the bottom of our website, we have a fast footer that show the quick information, the course we learn, some quick links, and our team member as well. About our wireframe, we do a little bit same as our website we built, but the information here on the website is just blank because we changed it during coding. So in a wireframe, we are planning a lot of ideas, some basic and informations. Then we do our final design that is similar to our current website. Our website and the wireframe will follow the Nielsen heuristic, ensuring that users can feel comfortable and interact with the website without hesitations, making user-friendly design. Regarding the personas, well, our research and user data collections reveal that users have distinct needs for accurate indigenous data and easy-to-use tools tailored to their roles. We developed the 3 personas representing key user groups involved in the Closing the Gap campaign. Non-Indigenous teacher called May Parker, a policy advisor called Margaret Edison, and Torres Strait Islander community organizer called Melati Siahi. This persona will help us understand the diverse user goals and challenges. For example, my non-Indigenous teacher needs accessible tools to create a clear table to effectively teach Indigenous topic in her classroom. Or Edison's, a policy advisor, require precise and culturally appropriate data to develop evidence-based policies that supporting closing the gap campaign. Meanwhile, Millet, a community organizer from the Torres Strait Island, seeks trustworthy website and tool to access real data to empower community advocacy and proposal. So bring these three personas, our team keeps real user front and center, ensuring every design and feature decision support their specific goals and improve their experience engaging with indigenous data. This approach helps us build a website that is both culturally respectful and practically useful across the education, our policy, and the community advocacy contents. Next, we will talk about our main outcome pages. In the main outcome, you will see that we highlight the outcome number 1 and outcome 5, some information about, and the 17 outcomes that are required in the step A to show the 17 outcomes, social economic outcomes of the national agreement in the Closing the Gap campaign. So you can select each outcome you want to see by clicking this circle button. And this outcome will automatically switch to another one each 5 seconds. Next, I would like to show you about our front-end design of outcome 1 and outcome 5. We have created the 3 top buttons for user to click of the health chart, age chart, and education chart. In health, you can click any of these. If you click the region, which means that you select all the regions, and you click the next button, click the year you want to look at, then select any health conditions, non-indigenous, male or female, the value of percentage, or the value and ascending or descending as well, and submit. When you click submit, follow from the filter, they will show the table that based on the user needs for data. About the similar here, we have the comparisons by regions and some show similar filters with disparities filters and suggestions filters. You can do the same filters like on the top, including the regions, year, select any health conditions, maybe non-indigenous, now, and the number of pounds you want to look at. It will pop up the table same like this with the result. Age, I will click time on next regions. I will read next maybe from 0 to 29. Indigenous, male, value, ascending, and submit. Move on to outcome 5. We'll also have 3 brands of health charge, age charge, and education charge. This quick link on top will guide user to based on their needs about the health data or age data and education data. Similar to the outcome 5, we also have the level same filters with regions, mean you select all the regions in Australia. Or time, that means you select the 2016 and 2021. Maybe blank. Next, health conditions, asthma, indigenous, not indigenous, no percentage, and ascending definite. And here we have choose similar filters with the disparity filters and choose projection filters. Molina 2021, maybe asthma, indigenous, now 25. Part of the tables of results. Under disparity, we will also have the same with click the time button. Asthma, female, disparity, ascending and descending, and click submit. It will pop up the table as well. And there's one thing that if you click missing any buttons in the filter, it will pop up the notifications that show you need to complete all the required views before submitting. This will announce the user that they forgot to select any filters that left behind. In age and education, maybe I will choose disparity filter with the 2016 or 2021 year 12 equivalent, no disparity, and ascending with submit. We will click in the progression filter, we will click bachelor degree, email, positions, and ascending. Click submit. And it also pop up the result. So that's how we create the website with the outcome 1 and outcome 5 with the filters with showing the health chart, health table, age table, and education table.
Hello and welcome to the second part of our presentation. In the first part, Tao has already talked about users and their functional and data needs. In the second part, we'll take a deeper look at system design and architecture. First, I will provide context for this section through showing the data provided and summarizing the required data and functionalities. Then we'll see what objects and functions need to be implemented and see the sequence diagram for filtering data to the user, which will help us better understand how objects and functions work together. Finally, we take a look at how the team has decided to design, process, and optimize the database, as well as how we have implemented the dynamic SQL builder using Java, and a demonstration to show that it works. We were provided with 9 Excel files. In short, each category has two files for 2016 and 2021, except for health conditions. Education has 2 extra files for non-education as well. And LGAs are provided in a different formats than the category files, and there are 2 files. Notable points include that there is only 21 health data, not 16, and LGAs in 16 are different from 21. These 2 points will affect how we design the database. The data provided for the categories are in this structure, where the identifier is the LGA code and each field is in the format of category value, status, gender, which means there are lots of fields and only as many rows as there are LGA codes. This makes it hard to query for data, so we have to change it later. To summarize the functional and data needs, There are two main points, including the landing page, which has all of these information, and filtering functions, which is the core of the website and the core of our projects. Filtering functions can be divided into four different types: overview, regional analysis, disparity analysis, and gap progression. This can be further explored on the website. For the purpose of this presentation, we only have to worry about overview by category. There are also additional functionalities, including sorting and ranking the results and percentage values besides the frequency values. In order to implement the above requirements while maintaining modularity and singularity of concern, we split the system into three distinct parts: front end, which is handled by instantiated handlers, such as outcome 1 page, outcome 5 page; back end, which includes the database and is handled by the JDBC connection class. This is a static class, and a static class in the middle to connect handlers to JDBC connection. To help with defining values and to create a unified structure for filters, we have defined a definitions package and a lookup argument struct or class. This is a sequence diagram showing what happens when a user submits the filter to when they receive the information. And as you can see, it uses the three main classes that we talked about earlier. When the user submits filters, the handler class is instantiated and it gets information from the post request, which it then sends to app helper to parse into a lookup argument. This lookup argument contains all the filter information and is the only required parameter to be passed into JDBC connection, which then uses those filters to choose the appropriate querying function, because there are four, as we talked about earlier. Then afterwards, it gets the data and passes it all the way back to the user. The main points to look out for is how app helper communicates with JDBC through this lookup argument class, and how the handler just passes this HTTP context into app helper without worrying much about the logic at all. Okay, now we move on to the database. As you can see from this DB schema, we have broken up the category value from status and gender into its own field. Besides that, we've also added a year field because we decided to combine 2016 and 2021 tables into a single large table. This significantly increases the number of rows for each table, because LGA code multiplies by the number of category values multiplied by 2 for 2 years. But it reduces the number of fields, and that makes it easier to query. We only have to worry about category value through where operations instead of constructing a column name to select from. And in the end, from 9 Excel files, we have 3 files, one for each category. And Yeah, we have 4 files, one for each category and one for LGA information. This is our ERD showing how the tables relate to each other. They don't relate to each category unless through LGAs, where each LGA is related to the category by a one-to-many relationship, and the category relates to LGA by one-to-one relationship. Okay, finally, the dynamic SQL builder in Java. Consider the case where you have to filter for this simple information: indigenous females with asthma in all regions in 2021. That would result in a SQL statement like this. Now, if we had to use if-else statements for indigenous and for the filters, it would take 6 if-else statements just to select one column. This could be optimized by putting everything into a single line, and that is by storing query syntax into the filter value itself. But the problem is that filter values have to be unified and they have to store a query syntax. This must be done using enums defined in definitions.java file. So basically, this filters.getStatus is a lookup argument containing a definitions.status enum. This is what the definition looks like. In conclusion, this dynamic SQL generator ensures that the code remains clean, flexible, and modular. To demonstrate that it works, just take a look at this function, which will filter health condition of asthma of indigenous female and ordered by, let's just say, value from most to least. Yeah, and we see that it works. That's all for my parts. Thank you for listening.